Now we are continuously talking about oscillation, of course. So session 1 में we have some topic, no, free oscillation का expression. So I'm just writing that as LC oscillation or LC circuit, जिसमें we have an inductor, means a coil, which we can term as an inductor, and a capacitor, which is fully charged. So capacitor के दो प्लेट है, positively charged plate, negatively charged plate that can be discharged, of course. So potential across inductor is VL, potential across capacitor is VC. Now this is closed circuit. So as this is closed circuit, by Kirchhoff voltage law, that is Kirchhoff second law, KVL, by KVL, summation of V is equals to 0 across any node or any point of a closed circuit. So here we have VL plus VC, which is equals to 0. For capacitor we know Q is equals to CV. Therefore V कितना हो जाएगा? Q divided by C, where C is the capacitance of capacitor, Q is the total charge across the plate, and V is the potential across the capacitor. So VC can be written as इसको small भी लिख सकते हैं. So Q divided by C, simple. Now what will be the VL? Now VL is that induced EMF. Think of electromagnetic induction, Lenz law. जब ये डिस्चार्ज होगा तो करंट जो पास होगा, so Lenz law जो है, it will oppose the change. That is the Lenz law. The tendency of induced EMF is to have in such a manner so that it opposes the cause which has produced it. So at some point external circuit, so this will be positive, this will be negative, so that it can oppose that, and that will be minus L times di by dt. Why minus? Because this minus represents the opposition, okay, the induced EMF. This is not the actual EMF across it, it is induced EMF, जिसे हम VL लिख रहे हैं, that is only EL, they are equivalent. So VL over here will write it as minus L di by dt. But if you just want magnitude, then we are fine with L di by dt. Now again I is rate of flow of charge, that is dq by dt, okay. Q by C is equals to 0. So second order differential equation, again d2q by dt square plus q by C is equals to 0, which gives us d2q by dt square plus so 1 upon q 1 upon LC. Don't you feel like this is something as d2x by dt square plus omega square x is equals to 0, where x was displacement and the x ka hi second order differential part. Here the q is something which is flowing, that's charge, and uska second order differential. So this LC can be equated with this. So omega square is 1 upon LC, omega will be under root of 1 upon LC, that is angular velocity or angular frequency they term as. Omega is 2 pi f, 2 pi f is under root of 1 upon under root of LC, then frequency becomes 1 upon 2 pi under root of LC, and this is the resonating frequency when XL is equals to XC. We can also discuss that resonating situation in fourth module, where which is resonance. That fourth module itself is a resonance. There also we can show this XL is equals to XC, so that we get the maximum current like this, no? The current is maximum for particular and resistance is low, it's minimum. So even though it's minimum, it's resonance only, because it is giving impedance is minimum and the current is maximum for that particular impedance, which is represented by Z or sometime like this. Okay, so this is for the session 1 LC circuit. इसी को मैं एक्सटेंड करूंगा सेशन 2 डैम्प्ड इक्वेशन ऑफ एलसी सर्किट. जिसमें हम ये एलसी सर्किट में एलसीआर सर्किट ले लेंगे। एंड अगेन जैसे स्प्रिंग ब्लॉक सिस्टम में वी डिस्कस्ड इन फर्स्ट सेशन ओनली वी कंसिडर रिस्टोरिंग फोर्स विच इज माइनस के एक्स, इन सेकेंड सेशन इन डैम्प्ड माइनस बीबी भी कंसिडर करते हैं इन द सेम मैनर। ये फर्स्ट सेशन में सिर्फ एल और सी कंसिडर कर रहे हैं, थर्ड सेशन में डैम्प्ड होने वाला रेजिस्टेंस भी आ जाएगा, रेजिस्टर भी आ जाएगा, इसका रेजिस्टेंस होगा, तो दैट विल आल्सो कम इनटू द पिक्चर और उसको भी लिखेंगे एंड दैट वे द थिंग्स विल गो।